This is the 22nd video in my Casting Shadows series, and it's about getting a shadow of a curve using different views. And it's in my book, Ellen's Guide to Casting Shadows, on Amazon. Orthographic projections represent three-dimensional images in 2 dimensions. Vertical projections, called elevations, are perpendicular to the ground. The front elevation is what we see when we walk up to a house. A section is a vertical slice here from A to B on plan. A side elevation is looking at the side of the house like this. Horizontal projections are parallel to the ground. The ones I show here are a plan of the roof looking down at it and a floor plan. Projections meet at the ground line. Points where elements hit the ground line, here some in black dots, are called traces. The vertical projections connect to the part of the plan to which they belong. So the section connects to A and B on the plan, while the side connects to the right side of the plan. The front elevation, the side elevation, and the plan show 2 aspects of the height, length, and width. So the front elevation and the side elevation will give you the height. The front elevation and the plan will give you the length. And the side elevation and the plan will give you the width. Here are 4 ways to find the shadow of a dot on a vertical wall. So this is the front elevation, this is the plan, and this is the side view. So this is the dot, and we're trying to find its shadow down here. So if you happen to know distance x and y, then you can find the shadow that way. If you know the light direction, that's great, but you have to also need to know distance x or y. Now, in the plan view, we're looking down at the dot here, which is in front of the wall. The wall is where the shadow is. So transfer the position of the dot down to plan, and then draw a light ray from plan to the wall. And where it hits the wall, transfer that up, and that would be the shadow where it intersects the light coming down from the dot up here. Now, on the side view, we're looking at the wall here, and the dot is in front of the wall. So we transfer that position over. We draw a light ray from the dot to the wall, transfer that position back over here, and where it intersects this light is where we find the dot, this shadow dot. Let's use these 4 ways to find the shadow of a horizontal line on a wall. So here's the line and here's the shadow. And if we know x and y, we can find the shadow. If we know the light direction, we can also find the shadow, assuming we also know x or y. In the plan view, the line is still a horizontal line. We align these 2 vertically, and then we send light rays from each end of this line to the wall to find the shadow on the wall. Transfer that information up, and where it intersects the light is where you would find the shadow. In the side view, the line is sticking out from the wall. Send a light ray to the wall, transfer that information over here, and where it intersects the light are 2 ends of the shadow line. Let's use these 4 ways now to find the shadow of a curve on a wall. So here's the curve, and we're trying to find this shadow. If we know x and y, we can pick a few points on the curve and find its shadow on this curve. If we know the light ray direction, we can draw those. But another way of doing this, since this is a quarter of a circle, is to find the center of the circle and draw a light ray down to the center of the circle for the blue shadow. And once you have the center and the radius, then you can draw these quarter circles. If you want to use the plan view, the curve looks like a line when we're looking down at it. So it's a horizontal line on plan. These 2, again, align vertically, we send the light rays to the wall to find the shadow and then transfer that information up. And when it intersects the light, we find points on the shadow. If we're using the side view, it looks like a vertical line. Send light rays down to the wall to find the shadow on the wall. Transfer that information over to the front view, and where it intersects the light are 2 points on the shadow. Here is a real live situation, so let's see if the system works. And it's a towel rack against an almost vertical wall. You can see it's not quite vertical. And you can see that we see the shadow here and the shadow here. But if we don't see those shadows, we should be able to find it using this system. So this is the front view and this is the side view. So start with the side view and draw a light ray from the top of the pole down to the wall. And let's just consider this one line, the wall. And then transfer that position over to the front view and draw a light ray down, and where it intersects this line is the top of the shadow that goes down like this. Now you can do the same thing with the little one. Draw a light ray from the top down to the wall, transfer that position over to the front view, and where it intersects the light is a point on the shadow. But the problem with this is that this light direction is about 45 degrees with the horizontal, and this light direction on the front view is almost vertical. And that's what usually happens. Usually light directions are not the same on the two views. Architects use a 45-degree angle in both views, but that almost never occurs. So in order for this to work, we need to know the two light directions. And so we need something else in the picture to tell us what those light directions are. But once we know that, then the system works. And I have 3 suggestions when drawing these images. First of all, use color if possible. Second, mark with dots, as I did here, the beginning of and end of each line, and only use the lines that are necessary. So please remember to subscribe and check out my book on Amazon, Ellen's Guide to Casting Shadows.